Here is our homework video for the asymptotes lesson. Okay, first thing I'm going to look at, I am plugging in infinity into this function. I'm plugging in very, very large numbers. And I've talked to you about this, and go watch the video again for why you are able to cross off 299x and 12,345. Because it'll be like adding very, very small decimals to a very large number, because 2x squared grows the fastest. Now, two ways to think about this. You can either say, all right, we have slower growth in the numerator and faster growth. Why is it faster? Because x cubed will dominate the growth compared to x squared. If you think about fractions where you have slow growth in the numerator, fast growth in the denominator, so I'm adding ones in the numerator, but I'm multiplying by 10 in the denominator. What is happening to these fractions? They're getting smaller and smaller and smaller, approaching 0. That's one way to think about it, slower over faster. You are able to, in this situation, since we just have x to powers, simplify this. 2x squared over 0.1x cubed. I could simplify this. It turns into 2 over 0.1x. I'm able to cancel 2 of these x's and 2 of these x's, leaving 1x here. If I found the limit as x approaches infinity, I would have a number divided by infinity. And again, some number divided by something that's getting very, very, very large is going to be approaching 0. Okay? So that or this. Just going to write it here for the key. Okay? Next one. Limit it as x approaches negative infinity. Okay, let's be careful. Because if you say, okay, faster over slower, and when you have something that's fast growing in the numerator and slow growing in the denominator, you're thinking, okay, 10, 100, 1,000 compared to like 1 and 2 and 3. These fractions are getting larger and larger and larger and larger. But I want you to be specific. Is it getting larger and larger and larger in a positive fashion or in a negative fashion? So you need to check your signs. Now, one way to check signs is to go back and say, okay, well, 2x cubed dominates negative 3x squared. 4x will dominate 99. I have 2x cubed over 4x, which simplifies to be x squared, or you can say 2x squared or x squared over 2. If I plugged in a large negative value and square it, it will become a positive. I'd have a positive value divided by a positive value. This is why I have positive infinity. So just because we have a negative infinity does not mean this is negative infinity. Turns out it is positive. You could have gone back to the original and you would say, okay, plug in a negative, cube it. That'll be a negative. Plug in a negative times 4, that'll be a negative. So you'd have negative divided by negatives in each time, which is why we are approaching positive infinity. Okay? Same deal. Goes away, goes away, goes away. I could either go negative 5x cubed over x squared, or notice that I'm going faster over slower. I'm going to be careful though. Either I can cancel and see that I have negative 5x over 1. If I plugged in negative infinity, I'd have a negative times a negative. That is why this is going to end up being a positive. And here, it would be like negative 5 times negative 10, negative 5 times negative 100, negative 5 times negative. That's why I know it's a positive. So those two examples you're not always positive infinity. Sometimes it's negative infinity. If this was a plus 5x cubed, then this would be a negative, and this would be a negative. So don't assume it's always going to be positive infinity. Don't assume it's always going to be negative infinity. You have to check your signs. Whenever you are answering infinity. Okay. Remember, sine x is a no-growth function. It's one of our slowest growing functions. It's a no-growth function. It grows slower than x. It grows slower than the square root of x. It is no growth, so in this situation, I can ignore it. Log x, one of the slowest growing functions. It grows exponentially slowly. It is the inverse of e to the x, which grows exponentially quickly. Log x grows slower than 2x. This is gone. So, in this situation, the algebraic way is probably the easiest way to find the answer because we notice that the growths cancel. If you have the same growth divided by the same growth, you end up having the coefficients of the growth. This is all about, do you understand relative growths? X to the 99th, faster than x. E to the x faster than log x. Now, in this situation, you cannot algebraically simplify x to the 99th over e to the x. Instead, you need to do it this way, where you say this is a slower growth over a faster growth. Slower growth over faster growth. Approaches 0. All right, this guy. Well, it looks like I just have 2x and 3x. Looks like I want to cancel the 1 and 2. Just be careful. Note that if you were to distribute this, you'd have 6x squared plus some other stuff. Well, 6x squared will be dominating the growth of the numerator. In the denominator, I just have the fastest growing term, which is the negative 5x squared. Now, you can either, you could do this in terms of like same growth coefficients, but I prefer that you understand or are comfortable with the algebraic simplification because the rest of the stuff does not matter. And this simplifies to be negative 6/5. If I put a negative infinity here, it would still simplify to be negative 6/5 because it's either positive over a positive or it would have been a negative over a negative and the coefficients would stay. So just keep in mind that. Be careful. We think, oh, 3 doesn't grow, cross it out. Don't cross it out. Because if we look at this fraction and I'm plugging in infinity in for the x's here, we have slower over faster. The 200 is not going to matter. Slower over faster approaches 0. So it's essentially 3 plus 0. The 3 does matter because that's my answer. Now, if it's 3 plus infinity, the answer would be infinity, and the 3 wouldn't matter. So that's why we're going to be careful. This example, it's a classic example. We're plugging infinity in for x. I only just have 2 terms. I can see that this cancels. I could just write it right off the bat as 200 over x. If I plugged in infinity for x, it would be like the cosine of, remember 200 divided by infinity, that'd be approaching 0. It'd be like the cosine of 0, which is 1. And that's my answer, 1. Square roots, be careful. It really helps to do the algebraic simplification for these square roots. Because depending on which direction, you're going to have two different answers. Let me show you. I can cross off the x because I got x squared. I can cross off the 15. Now, this simplifies to be negative 2x over root 16x squared. I can simplify root 16x squared to be 4, but this x squared becomes a plus or minus x. Now, this is only just to kind of know that I could have a positive or negative. Now, yes, the x's will cancel, but this is telling me my answer could be positive a half or negative 1/2. What I'm going to do is go back either into this or this and check my signs. Now, if I plug in a positive value into the numerator, negative 2 times a positive value would make the numerator a negative. The denominator, since I'm squaring the number, any number squared is positive, times 16 is positive. This is insignificant. Square root of a positive remains a positive. That's very important to know that, the square root of 16 is just 4, not plus or minus 4. The square root of x squared, that's the plus or minus. Okay, so this answer is actually the negative 1/2. But watch how in the other direction, if it's the same deal, I'm just going to check my signs. I'd have a negative times a negative, gives me a positive, and I'd have the square root of 16 times a negative squared. That's going to be a positive. So because I have a positive over a positive, that's why this answer is positive a half. Let me just write that over here. I did negative 2 times a positive over root 16 times a positive squared, negative over a positive. Now, I don't like this. You need to change the question for this one. This needs to change to a plus. So, if you watched the video or did the key, hopefully you saw this. Because if I had a negative, then this would be 8 minus like a huge negative number, which would have been a negative under a square root. We don't have to worry about that. Instead, let's just do this. We're plugging in negative infinity. I got a plus 4x squared. Okay, well, 3's gone. 8's gone. I get 4x over root 4x squared. That simplifies to be 4x over 2 times plus or minus x. That becomes plus or minus 2. The x's cancel. My answer is positive or negative 2. Check my signs to find the specific value, either positive 2 or negative 2. Well, I'm plugging in negative infinity. Plugging it into the original, I got 4 times a negative over root 4 times a negative. Oh, actually, no, yeah, it would have been bad. 4 times a negative squared. So the denominator would end up being a positive. Because the negative squared is a positive, times 4 is positive, rooted stays positive. The numerator would be negative. So this is negative 4 over 2, which is why this answer is negative 2. Or I'd rather just say this is a negative over a positive. Okay, great. Find the horizontal asymptotes. When you're asked to find the horizontal asymptotes, you need to look in two different directions, in the positive direction and in the negative direction. And I gave you these examples for a reason, because If I look in the positive direction, e to the x wins. 2 to the x means nothing. 5x, 2, will be insignificant compared to 3e to the x. It's like adding a very, very small decimal to a very, very large number. My answer after canceling the e to the x's is negative 1/3. Fantastic. But if I plugged in negative infinity, reminder, a number to the negative infinity is like 1 over the number to the positive infinity, which is approaching 0. If I go in the negative direction, 2x wins. Negative 5x wins. The answer is negative 2/5. Because in the negative direction, e to the x doesn't grow. It approaches 0. So it would be like 2x plus or minus 0. 0 minus 5x. Okay? Same guy here. Got to look in both directions. If I look in the positive direction, this is 3 to the x. Definitely goes faster than 2x squared. So I just have 3 to the x. 4 to the x. Definitely grows faster than 5x squared. 4 to the x wins. Now, careful. This is not negative 3/4. 3 to the x is a different type of growth than 4 to the x. 4 to the x grows faster than 3 to the x. Slow over fast, we talked about 1, 2, 3, 4, 10, 100, 1,000, 10,000. Those values are going to be approaching 0. So in the positive direction, I'm actually approaching 0, not negative 3/4. In the negative direction, 3 to the negative infinity is 0. 4 to the negative infinity is 0. So I just have 2x squared over negative 5x squared. That simplifies to be negative 2/5. So for both of these, I have two different horizontal asymptotes. Vertical asymptotes. Now, you won't always be told, hey, this is a vertical asymptote, heads up. Now, remember, with vertical asymptotes, it's typically when we have a number divided by 0. But it's not really 0. It's going to be like a number divided by something infinitely small and positive, or infinitely large and positive. And we remember, if we have this situation, positive divided by something infinitely small and positive, we're going to be infinitely large. We just have to be careful with our signs. If I have something that's a number divided by something infinitely small and negative, well, then it would be negative infinity. But if these change, that this is a negative number, this would be negative, and this is a negative number, this would be positive, okay? Now notice, vertical asymptotes, numbers over 0, you are given specific numbers to make the denominator 0 and to make the numerator not 0. Okay? Now, here's what I'd ask you to do. Use a number line. 3 from the left. Think about 2.999. If you take 2.999 and plug it in here, it would be something that's very small, but it would be positive. Okay? You're thinking like 0.001. Now, in the numerator, I don't have to plug in 2.999. Just plug in 3. Because 2 minus 3 is negative 1. I don't care if it's negative 1 to the left or to the right because it's still negative. I care about 0 from the left and 0 from the right because it changes the sign. So this negative I'm just writing it down for the key. This negative value divided by this infinitely small positive value will give me something infinitely large and negative. Now, what we are discovering is that if I were to graph this function around the asymptote x equals 3, I'd be approaching negative infinity to the left of it. And that's our goal with these vertical asymptote questions, is to understand the behavior of the function around your vertical asymptote. This is a great one, okay? Let's be careful here. -4 from the left. -4 from the left of -4, I'm thinking -4.0001. If I take that number and square it, well, -4.001 times -4.001 is going to give me a number a little bit bigger than 16, maybe 16.001. If I subtract 16 from it, I'm going to get a number that's very, very small, but positive. Meanwhile, in the numerator, I don't care if it's to the left of 8 or to the right of 8, because it's still going to just be a positive value. Now I have a number divided by something infinitely small and positive, infinitely large and positive. Okay, that's how we work through that. So this would have an asymptote at -4 and 4. To the left of -4, I'd be approaching positive infinity. Okay, that's what we determined. All right, same deal. -3 from the right. Here's -3. -3 from the right is like -2.999. How do I know that? It's very important to use this number line. That way you think, oh, to the right of -3. That's not like to the right of 3. To the right of 3 is 3.001, but to the right of -3, -2.999. So that is what we're starting with. Now I'm plugging that in to x squared. I don't have to worry about the numerator. The numerator will end up just being -1. I have to worry that it ends up being that negative, because 2 plus -3. Okay, so if I take that number and square it, it's going to be something a little bit less than 9. So I'll have 9 minus something a little bit less than 9, probably like 8.999. Okay, you can do 9 to the left. -1 divided by 9 minus something a little bit bigger than itself is going to be very, very close to 0, but positive. Negative divided by something infinitely small and positive is infinitely large and negative. Here, this one, -5 from the right. Literally all the examples I gave you are tricky examples that we'll probably see on tests. Rather than the easy examples, you see these harder examples. If you know how to do these, you can handle anything. So I got 3 times -5 in the numerator. In the denominator, I'll have 5 plus -4.9999. This is going to be something that's very, very small and positive, divided into something negative. This will be something very, very large and negative. Okay? Last 2 questions. F of x has a vertical asymptote at x equals 3. Got a horizontal asymptote at y equals -2. What must be true for a and b? 2 different situations, right? Let's think about the vertical asymptote first. Vertical asymptote at x equals 3. What is true about all of these situations where we have a vertical asymptote? We have a 0 in the denominator divided under a number. Vertical asymptote must be a number over 0. So, for my vertical asymptote, the denominator must equal 0 at x equals 3. That's an equation to solve. 3 squared minus b must equal 0. 9 minus b must equal 0. B's got to equal 9. Great. Now, horizontal asymptote. What do we do for horizontal asymptotes? We look at the limits as x approaches infinity. Now, we're told that We just have one horizontal asymptote. So that means no matter what direction I look in, positive or negative, I better get -2. Well, ax squared minus 3 over x squared minus b. Cancel the 3's. Cancel the 3, it's insignificant. Cancel the b, it's insignificant compared to the growth of x squared in the numerator and x squared in the denominator. Okay? Because we're plugging in very, very large numbers. This simplifies to be ax squared over x squared. This is just a. Well, a has to equal -2. Same deal here. Vertical asymptote, x equals -1. That means the denominator equals 0 at x equals -1. Plug in -1 to the denominator for x. Set it equal to 0. -1 minus 3c equals 0. -3c equals +1. C is equal to -1/3. And a horizontal asymptote, the limit as x approaches infinity of f of x has to equal a horizontal asymptote at y equals 2. So limit as x approaches infinity of 3 minus dx cubed over x cubed minus 3c cancel. Cancel. Why? X cubed will grow and dominate what's going on here. X cubed will dominate here. The minus won't matter. This simplifies to just be negative d x cubed over x cubed or negative d. That's got to equal 2. That means d has got to equal -2. This is a tough lesson if you guys don't know what's going on. Hopefully this video helps. This is a tough unit if you don't practice. Review day next class, quiz next class, test the following class. This is gut check time. Let's go.